So we're going to focus on solving exponential and logarithmic equations. So let me get to the page we want. So we've got these properties you've been over in previous units before now. And so we're going to use all these properties in order to be able to solve these equations. So we've got exponential and logarithmic here. We're going to focus first on these two exponential. So the first one says solve for the given variable, round your answers to 3 decimal places. So when I look at number 1, it's got 2 to the 2x equals 16. Now, when we're looking at exponential equations, if we can represent the left side as a power with the same base as the right side, we want to do that. And 16 is actually equal to 2 to the 4th. So I can rewrite this as 2 to the 2x equals 2 to the 4th. Okay, so what this allows me to do is I can use the property of equality that says if one base is raised to an exponent and that same base is raised to the other exponent, that it can only be true if the exponents are equal to each other. So 2x equals 4, dividing by 2, and I get x equals 2. When I go to the next side, number 2, it says 5 to the x minus 3 equals 70. Well, I can't represent 70 as a power of 5, meaning I can't take 5, raise it to some exponent, and get 70. So what I need to do instead is I need to use logarithms to solve this. So my first step is to take the log of both sides. So I'm going to do log of 5 to the x minus 3 equals log of 70. And now remember, when we just write log and there's no base there, we assume that the base is 10. I'm now going to use the power rule to take this exponent and bring it down in front. So I've got x minus 3 times log of 5 equals log of 70. Okay, dividing both sides by log of 5. And I get x minus 3 equals approximately, because if I take log of 70 divided by log of 5, it's approximately going to give me 2.6397. And so I add 3 to both sides, and I get x is approximately equal to 5.640. And again, it's 640 because it tells me to round to 3 decimal places.